This conference will now be recorded.
Hi, good morning all. Welcome back. Yesterday we discussed about the services in Kubernetes. Service acts as a load balancer between the pods, and it will act as a service mesh as well. When app A wants to reach app B, it should use the service. Otherwise, the IP addresses are ephemeral. And we have discussed multiple types like cluster IP, node port, and load balancer. And mm, today we will discuss about the sets actually. Yesterday we already discussed one set called replica set. In Kubernetes there are four kind of set: replica set, deployment set, and daemon set and stateful set. Okay, now we'll discuss more about replica set. Kubernetes replica set. Replica set is nothing but you will get the more replicas to your pod, whatever the replicas you want. And then actually it is a part of deployment. We will discuss now what is deployment, why we use deployment over replica set. Okay, so let us see and then what are the drawbacks of replica set. Okay, so this is the replica set. I'm just giving Nginx here and then I will give Nginx here. Okay, app guestbook tier front end. So you know the syntax already. This is the pod template from here, metadata spec, what is the container, and this is the replica set configuration, how many replicas you want, how to match it, match the labels with the tier front end. Okay, kubectl apply -f01 replica set. Okay, replica set got created. Can check kubectl get pods. Now try to delete one pod. Kubectl delete pod. Now immediately it will create another pod. You can see 4 seconds. So the replica set makes sure the proper number of whatever the given replicas, declared replicas are running all the time. If some reason the pod gets terminated or someone does that accidentally, it will automatically create another pod. Okay. And let me check kubectl edit pod. Let me try to edit this pod. Okay, here you break the relationship between replica set like this, owner reference, and then you remove the labels. Okay, you remove the labels. Now come on. So I saved and edited still. Now you see 4 pods are running because what happened? I broke the relationship between the replica set and pod by removing the label and owner reference. Then replica cell felt I got only 2 pods now. I need to create one more to meet the replicas. Okay, so the replica set is purely matching the pods based on the labels. Okay, if you see the documentation here also, they will mention a replica set is linked to its pod via the owner reference and then the labels. Okay. Now, if I try to create one more pod with the same label, let us see whether that pod will run or not. Okay, API version v1 kind pod metadata name pod1 and then labels. Labels, what is the label it is using? Tier frontend. And then spec containers name nginx image nginx. Okay, now if you apply this and then check the pods, so it got created and then terminated. Why? Because you are trying to attach another pod with the same label to the replica set. Then what is the replica set actually? Desired 3, current 3 and ready 3. When you are trying to create another pod with the same label, then what replica set felt is I need only 3. I have already running 3. So I should not create this pod. So you should be very careful while creating the labels to different projects or I mean different applications in the same project. Okay, you should not use the same labels in the same namespace. So that is the with replica set, and then I will remove this. So here the point is replica set match the pods with labels. That's it. And here, if I want to upgrade the image like nginx, what is the nginx? If I try to upgrade the version, or let us take, let me delete this first. Okay, we have the CMD image here. We have two versions, V1 and V2. Now, for example, I create the replica set with V1. And then this is my application first version. Okay, it's good. All our 3 pods are running. Now I changed something in my code. Now the developer wants V2 version to be spinned up. If you try to spin up V2 version again with the replica set, you can see nothing will happen here because replica set only cares about how many replicas of the pod running. If you are changing the version of the image, it will not automatically update. So that's what the documentation also will say. Replica set ensures a specified number of pods are running. And then update. Let me check this. Okay, so everybody here the documentation says to update the pods with a new spec, you should use deployment. So that is because replica set don't cares about the image update or version update. It only cares about the number of replicas running or not. If you want another version of your application, what you need to do is you need to create a new replica set with a new name and then remove the old replica set. So that will become a manual job actually. If you see deployment versus replica set, let us say you have replica set A controlling your pods. If you wish to update your pods to a new version, now you should create replica set B and then scale down replica set A, and this is like a rolling update. Okay, so you need to scale down the replica set A and scale up the replica set B parallelly. Okay, for example, how you should do is, let us write it, you will clear. Replica set A is running and you got new version of the pod application. You need to change to version B. So in this case, what you need to do is you have to create new replica set P with one replica. If the new pod is in running, you need to scale down replica set A to 2. Okay, you got a new application, you need to change to version B. You have to create replica set B with one replica. If this new pod coming running, you need to scale down to 2. So now what is the state? Replica set A is 2 pods and replica set B is 1 pod. Now again, you need to scale up replica set B to 2. When new pod 2 comes up, you need to scale down replica set A to 1. Now the position is replica set A is 1 pod and replica set B is 2 pods. Okay, similarly you have to do the third one. So this is called as rolling update. Okay, there is no downtime actually. Parallelly, your Kubernetes make sure you have 3 pods running at a time. So that is called rolling update for zero downtime deployment. So usually you cannot do this in the VMs. If you have to do this, it needs a lot of manual work, but Kubernetes giving us an easy way to do this. So this is how you need to deploy your latest applications if you go for replica set. But practically this is not possible and it causes a lot of manual work. So Kubernetes came up with the approach called deployment, a deployment set. We call it as deployment or deployment set. Okay. Here they suggest to use deployment. Now let us see what is deployment. Okay, I will remove this. And if you see here, the pod is your replica set name hyphen 5-letter random word. Okay, that is created by replica set automatically. So now let us go for deployment. Copy this. API version app/v1 kind is deployment, metadata, Nginx deployment, labels, app Nginx, and then same like replica set. Spec is replicas 3 and selector. This is going to match the pod labels. This is the pod spec. Okay, what is the name, what is the image, everything, and this deployment will go and attach to the pods with labels app Nginx. Now let us use our one because we have clearly, this is also Nginx anyhow. Okay, kubectl apply. Now you get kubectl get deployments and kubectl get replica set comma pods. Okay, replica set and then pods. You see here, deployment created replica set automatically with deployment name hyphen some random word, and replica set created the pods. So deployment is one level higher than replica set. Whenever you provision deployment, it will create the replica set and then replica set will create the pods. Okay, now let me upgrade this to the new version. My application team came up with new version. They want version 2 to run now. Now let us see what happens. Better I show it in a split. kubectl get deployments comma replica set comma pods. No. Okay. kubectl get pods. Let us see. Watch. Okay. Just remember this is the world replica set. Now I am pushing it to the new version. can come and see here. You can see this came to running, and slowly one by one of old replica set got deleted. So whatever I explained here manually, that is done by deployment automatically. It will create a new replica set, and then slowly it will bring up one pod and then terminate the old pod. Okay. That is the configuration. They did not mention properly here. Kubernetes deployment max search. This is called as rolling update. If you want to control more, what you have to do is strategy. This is the strategy. Now let us check this if we get any documentation here to provide the strategy. Kubernetes deployment strategy, rolling update. Okay, so now let us copy this. And let us see what is this one. Okay, strategy is rolling update and max unavailable. For example, if you have 10 pods running, you are okay for one pod to be unavailable at the time of deployment. Okay, that is this one. Max surge 1. It means 10 old pods are running. Surge means higher. You are okay for 11 pods to be running instantly. How this 11 pod will run? A new version pod will run, right? So this is 11th pod. When this pod comes to running, then only you will kill the old one pod. You will kill one old pod. So for this fraction of seconds, you have 11 pods running. Okay, so you are mentioning to the Kubernetes, the max search should be only one of new pod can run. If you say max search is 5, then what Kubernetes will do is it will create 5 new version pods. Now it will become like 15 pods will be running, and then it will kill 5 old pods at a time. Okay, that is the strategy. Now we can see that clearly. Let me say, let us delete this. Now say I have any 10 replicas, max and available one, max search is 1. Then Kubernetes will do one by one. 2, 3, 4. You can see 10 pods coming up. 10 pods came to running. Now if you update to the V1, now you can see at a time only one pod will become. So since it's doing in a fraction of seconds, you are not able to really grab it. Okay, but what happened behind the scenes is one pod comes up and then one pod will become unavailable. Another pod will come up, another pod will become killed, the old version. That is how you will control your rolling update strategy. Since this is a Nginx, it will come to running very fast. But if it is a real-time application, you can observe that change. Any doubt still here? So mostly 100% time we use deployment for the applications. So you'll get what is replica set. You can say replica set is to maintain the number of pods, and then you will ask somebody will ask what is deployment in Kubernetes. Deployment is way of a strategy to deploy the applications into the Kubernetes with particular number of replicas, and whenever there is a change in image version, we can redeploy the pod. Okay, so deployment is the one we 100% use in our projects. Okay, deployment maintains the number of replicas and version changes, everything deployment will control. So you need to explain how the deployment will control. Deployment will create one replica set, and replica set will create the pods. If there is a new change in the application version, deployment will create the another replica set and perform the rolling update automatically. Okay, this is the deployment, and then you can check the status of your deployment. So in our automation of deployment, what we'll do, we will push new application. It may or may not run, right? If it is not running properly or some problem, we need to roll back. Usually what you do in a VM deployments, if you deploy the application, if it is not running properly, then you will get old artifact, stop the server, remove new artifact, and then copy old artifact and restart the server. So this is how you do the rollback, right? Either manual or automation. But same way in Kubernetes, it can do it in a fraction of seconds as well. You can check the status whenever you push the deployment. You are not sure this will come up or not. Okay, if you want to check the previous status of your deployment, you need to issue this command kubectl rollout status nginx deployment. So we can see this also when we are deploying our microservices. We will do it everything through the Jenkins. In Jenkins, what you do in one stage deploy, you will issue a command kubectl apply -f 02 deploy.aml, and then stage rollback. Here you will check with this command. If success, proceed. Pipeline success or deployment success. If failed, you need to roll back. Okay, how you roll back? Here you have the commands to check it. You check the status and then now you can see the history of your deployment. This one I want. Okay, there are two versions till now for our deployment. Version 2 is the latest. You want to revision back to the version 1. Okay, now if you do this, you can see here. Okay, this is the details of version 2. Okay, this is the details of version 1. What was the version 1? It is the image is cm2 colon v2. Okay, it will give you the version 1 details. Now if you want to really roll back, then the command is this one, kubectl rollout undo deployment to revision 1. Okay, revision 2 is the latest and that got failed. Now you want to go back to revision 1. Now you can check here. Immediately your application got to previous version. Okay. You can scale like we have seen yesterday, scaling the replica set with new replicas. Yeah, this is all for deployment. We will use it with our microservices anyhow. User catalog, all those things are going to be deployment. So you will get the questions on how can you check the rollout status and rollback. You can mention these commands. Any doubts still here? Okay, usually we don't do the pods directly. We always go with deployment that internally it will have the pods structure here. Okay, and then we will go for daemon set. So what is the difference between daemon set and deployment set? Daemon set is, daemon means a software running. Daemon set, if you run daemon set, Kubernetes will deploy pod in each of the node. Suppose we have two nodes. If you create a daemon set, what Kubernetes will do is it will schedule a pod in each of the node. So in what cases it is useful? For example, like monitoring, like you need node metrics and logs logs collection from each node. So in this case, you go and set up a daemon set that will deploy your pods in kube system namespace. This is the administrator work actually. Okay. So administrators, when they want to set up some monitoring like node metrics collection and logs collection from each node, they will create a daemon set in a kube system namespace. You can check that here. A daemon set ensures that nodes run a copy of pod. It means a pod will run in each and every node. For example, in between, if you add a new node, again daemon set will make sure another pod will come to running state in that new node. Okay. So daemon set will continuously watching. If any new node comes up to the Kubernetes cluster, it will schedule another pod. If any new node removes from the cluster, it will remove that pod. Okay. Some typical uses of daemon set are logs collection, and node monitoring collection by collecting the metrics of the node. Okay, so this is the syntax. Let us go and check what is it. API version, kind, metadata, same, spec selector, same. You don't need to mention replicas here. By default, Kubernetes will take care based on the number of nodes you have. And then so these keys are just to, if there is already a pod running, it will not create that. And control plane, you see, if there is a master node, you no need to run your pod on the master node. So there is no schedule. So not to run your pods on master node, you are providing this information. Okay. And if you want the collection of metrics from master nodes also, you can give. Usually master node will have separate monitoring. And then this is the one. FluentD is to collect the logs from your nodes actually. And then this is where it get the the logs of your Docker containers. We saw them already. Where Docker containers, there we will have the logs related to your containers. Okay. Now let us apply. And then you can see kubectl get pods. It's not a normal namespace, it's an administrator namespace called kube system. Normal users cannot say this. Okay, so these containers collects the logs of all other containers and then pushing them to something called Elasticsearch. Okay, that is configured in this image. You need to provide the path, then it will always read that path and then pushing the logs to the Elasticsearch cluster. You need to configure this image for that. So in real time, you will configure this image and then you will push the logs. So we will see that while we are running our microservices. So this is about daemon set. Better I mentioned some notes here. Replica set. Make sure desired number of pods are always running. I can clearly write again for now, whatever we discussed. Deployment. Deployment is make sure desired number of pods running through replica set. Using replica set, you cannot update the image version. We can do it through deployment. Deployment performs automatic rolling update. That is the deployment, and then you can check the status. You can check the deployment status and roll back if something goes wrong. So that is deployment. Daemon set cluster admins setup. Daemon set usually for logs collection, node metrics. Daemon set is useful. It makes sure pod runs on each and every node. Okay, next thing is stateful set. All these are for stateless applications like your front end or back end, whatever. But what if you are running something called stateful applications which needs data? For example, your database, MySQL. Suppose I have a front end and this is calling the user pod. Ultimately, this user is storing the data in MySQL pod. Okay, if your front end pod kills, no problem, you can create another front end pod. If your user pod kills, no problem, you can create another user pod. There is no data actually stored here. All the data is stored in MySQL. Okay. So if MySQL pod runs, if you are not storing the data, then you mean you are losing the entire data of users. Okay. So this one, daemon set or deployment set, replica set, deployment is actually the stateless. It will not keep the storage. But if you want data kind of applications to run in Kubernetes cluster, you should go for stateful set. Okay, deployment is for stateless applications like backend API, front end. Deployment will not work for stateful applications which needs data like MySQL, ELK, Redis, RabbitMQ. So these are stateful applications which needs data to be persisted for long time permanently. So in that case, we go for stateful set. Okay, and another thing is, if you have kind of database applications, for example, how the database cluster will run is there will be a master and there will be slave. Slaves will never get the requests actually. The request will get to master and then master will send the request to the slave. Same like Jenkins. Okay, Jenkins master and slave. So what happens if it is a deployment is, for example, this is pod 1, this is pod 2, pod 3, like that. If pod 3 kills, pod 3 got killed, then the pod name will be changed. You can see here, this is a random. Pod name will be changed, then master don't know what is the random ID, then it cannot reach it. Okay, so but stateful set make sure your pod name will be same all the time, stable and unique network identifiers. And in deployment, all the pods for example 1 2 3 4, all the pods share the same storage. Okay, all the pods store the same storage, but in replica set each pod will have its own storage. Okay, so what will happen is if you kill this pod, another pod will be created with the same name and it will go and attach to the storage automatically. Okay, so this will be useful for a data kind of master and slave architecture, because while forming the cluster, each pod should know what are the other pods available in the cluster. Okay, like if you are running RabbitMQ in Kubernetes, each pod should know what are my fellow members. If your pod name is frequently changing, then this will not understand. Now let us check this practically, what will happen. But very rarely we use stateful set actually. It's a recent feature in Kubernetes. No one wants to keep their data in containers. Okay, and there is another reason. Deployments need not to have services, but stateful set should have headless service. I will see what is headless service and what is the difference. Deployment can have normal services like cluster IP, load balancer, and node port. There is one more type of service called headless service, that is the stateful set concept. Okay, now let us see this syntax. We'll come to the headless service. Let us see the syntax. Replicas 3, minimum ready seconds 10, labels, spec, and then volume mounts. Now I am giving 3 replicas. Let us see how this stateful set will behave. Now what is the storage class we have? kubectl get storage class gp2. Okay. Now I will apply this. Now you get to see the pods. Okay, first web0 will create and it will come to the running state. Then only web1 will create, and it's not a random ID. You can see web0, web-1, web-2. But if it is a deployment, all pods try to start at a time. But if it is a stateful set, pods will slowly come up. Ordered and graceful deployment and scaling. Ordered means web0, web1. If web0 is success, then only web1 will come up, then only web2 will come up. And when you are deleting, first web2 will be deleted, the next web1, next web0, like that. Okay, I think space problem. Let me delete the kubectl delete -f02 deployment. Why is it still creating? This is the image we gave. Some Nginx. kubectl describe pod web0. Invalid volume not found, does not exist. Okay, it should create some volumes here for the storage. Okay, let me delete and then check the syntax. I'm giving the storage class for automatic provisioning. Storage class is gp2. Storage class is gp2. Okay, let me give normal Nginx image. EBS. EBS. Okay, all pods got deleted. Oh, come on. What is the namespace? Is there any namespace? Okay, now it is trying to create kubectl describe web hyphen 0. Okay, got it created a volume here. You can see here 3 pods, 3 volumes are created. This one Kubernetes dynamic PVC. Web 0 is success, Web 1 is success, Web 2 is success. It will do a ordered and graceful deployment. And even I remove this pod, kubectl web 0. Again, you will get the pods with same name, web hyphen 0. So stateful set stores the network identity of the pods, but deployment will not store the network identity. Okay, and now it comes to the service part. So service is a headless service because of 2 reasons. In this data kind of environment, pod 2 wants to reach pod 3, pod 3 wants to reach pod 4, pod 4, pod 5. So like that, these pods should communicate internally. In that case, pod 2 wants to reach to pod 3. Usually how you reach the pod 2 from pod 3, like if you want to reach pod 2 to pod 3, you either you use IP address, okay, but IP keeps on changing. So for that purpose, what you got? Service. Okay, but service works as load balancer. If I hit the service of this stateful set, normal service, you don't know what IP you will get. You may get pod 4 IP or pod 5 IP also. Okay, so those are the reasons to use headless service. Now let us see what is that headless service. kubectl exec hyphen it web hyphen 0 bash. Okay, before that, let me get the pods hyphen o wide. Okay, kubectl exec bash. Now curl web 1 I want to reach. You will get the response nginx. Okay, now this IP address keeps on changing. I cannot call like that. If you use normal service, you will get random IP address from this based on the load balancing. But if you use headless service, what will happen is, if you want to reach web hyphen 1, then you can give the name of the service. What is the name of the service? Nginx. Now you are getting the response. Okay, so headless stateful set uses headless service for the standard pod identification. Any doubt still here? It's already delayed. Ravi, copy, funny.
No doubt, Shiva. Just we'll practice one more time.
Yeah, this is like a very important question. What is the difference between deployment and stateful set? I can write the description in detail in README and I will push it. Okay.
Sure, sure.
You will get the mandatory question. What is headless service? Headless service is nothing but cluster IP none. It will be useful in stateful set, and storage kind of applications need headless service to reach another pods within the cluster. So how it will reach is using this one, another pod name dot service name. If it is deployment, pod name keeps on changing. That's why we use headless service in deployment. But practically, we don't keep databases in containers in any project. Okay, but the concept is coming up. Maybe in future we may keep ELK or something in Kubernetes. That's all for today. Have a nice day. See you in next session.